The main problem is that students don't know what they're doing when they're calculating for something, or solving for x, or plotting something, or differentiating, taking the limit. In the mind of the student doing the calculation is that he doesn't know what he's doing. Also, you have the problem of plotting. Plotting is seen as this hard thing. It's too much time to plot a curve, and I can't be bothered doing it. And we'll expand upon what I mean in a second. So when you first begin getting introduced to the subject of math, you'll spend about 5 to 6 years doing just the operations, the basic operation of the addition, subtraction, multiplication, and division. You'll learn that if we added this unit to this unit will be the result. And we can subtract this one unit from the above unit to get this thing. And multiplying is just addition simplified. And division, and when you go on to tackle division, for example, you want to divide this shape into 2 even spaces or units, you'll just divide by 2. This is all well and good, but when you get introduced to functions, here is where it gets tricky, because suddenly you have to solve for x. And you will learn in algebra that to solve an equation, and we call this an equation because of this equal sign here, both sides are equal, and you learn to solve this equation by subtracting 5 from the 2 sides. And we do that to isolate x. This would give me x equals to -1. And people get too comfortable in doing these operations. You'll just have to subtract, add, or multiply, divide from both sides a number that will simplify the equation, and the result should be the isolation of x. This means solving for x. But what did you do actually? If you hold on for a second and think about it, what have you accomplished? You solved for x. What does this x represent? And this is where the problem is. If you know the answer to this question, well then congratulations, you've been paying attention. Let me spoil something for you guys. Algebra isn't supposed to make sense. In algebra, you'll always solve generally. That's why as you progress through algebra courses, you'll see that you begin by 2 plus 2 equals 4, and then x gets introduced, and then x plus 2 equals 4, and then 2 disappears, x plus a equals 4, and then the 4 disappears, x plus a equals b. Because what matters in algebra is solving for x. And the way to solve x will be the same no matter what these two numbers are. So we might as well call them a's and b's. This is what makes algebra hard. Because for the person solving these questions and problems doesn't have any picture in his head. He can't visualize anything to help him learning. For example, if I'm teaching something about cars, you'll immediately picture a car in your head. Or if you didn't, now you did. Why? Well, because your head has determined, your brain has determined. This is actually a good way for you to understand what I'm saying. But when I'm throwing x's and y's out in the air, your head now needs to learn an algorithm, a step-by-step guide how to solve a problem. Well, this becomes hard. That's why we introduced plotting, the plot of a function. With the power of plotting, now we can plot a function. I'll call this f of x, and this f of x crosses the x-axis on 2, on x equals 2. F of x can be anything that it wants to be. If I have plotted the curve of f of x, which in this case I have, I don't need to know the algebraic notation and expression of f of x. And actually there are techniques in which we can find the algebraic notation or expression of a function based on the shape of the function, But basically, for a human person, I know that when f of x is equal to 0, then x is equal to 2. That is evident based on the curve of f of x. On this point, f of x is 0 and the x is equal to 2. Then f of x increases as I'm looking from left to right. It reaches a maximum point. It begins decreasing and it begins increasing again. These are all useful information that we extracted just by looking at the shape at the plot of f of x at the curve. But unfortunately, in most cases, especially in school, will only be provided with the algebraic expression of f of x. That's why plotting is a powerful tool at our disposal. Let's say I have a function f of x equals to x squared. I will provide multiple different x's. In this factory, I'm calling f of x, and on the other side, I will get y's. And by plotting these different pairs, x's and y's, on the coordinate system, I can get the plot of f of x. So this is plotting, as we've discussed before, and help us visualize what we're doing right now and when we're working with algebraic notations and so on and so forth. And expanding further on the part of I don't know what I'm doing part that students struggle with, let's say that you're differentiating a function with respect to x. You know how to differentiate the function. Let me just put an example here. And you want to take the derivative of this function with respect to x. Using the power rule, we'll bring 5 down, multiplied by the function, and the power minus 1. So this yields 5 times 2 is 10. Times x to the power of 4. You've just found the derivative of this function here. But you have to take a second and think about what you actually did. You've just found the rate of change of a function. You've not only found the derivative, but you have to understand what the derivative is. You found the equation of the slope, the function f of x. Using this equation, we can find the slope of a tangent line on each point on this function. And we can also find the rate of change of f of x. We can find the maximum and minimums and critical points of f of x. These are all the things we've just accomplished. So understanding the point of calculation connects the dots with one another in your head, especially when you encounter different types of operators like the limit, derivative, and the integral, and so on and so forth. When you work with different kinds of entities, you work with sets, functions, work with matrices, vectors, complex numbers, different types of equalities, inequalities. Having an idea and a template in your mind will help you navigate through the problems much easier. And on the other side, what you will get from this is that you'll feel that you haven't learned new stuff at all. This was all just the basics, and it was obvious all this time, and I just didn't pay attention. Why? Well, because we gloss over all the important stuff and we go straight into finding an algorithm that helps me solve for x as fast as possible. What is the new technique I can do? I can memorize, solve for x. But at the end of the day, that will feel overwhelming because you're always learning new stuff and you will get overwhelmed. Let me just have one last example here. The limit of 1 over x as x approaches infinity. We may have learned a lot of stuff regarding the limits, but at the end of the day, what this question asks is, I'm plotting here the function of 1 over x. What this question asks is that as I go along x on the x-axis, and I begin approaching infinity, so huge numbers, what will become of my curve, this curve? What will become of the curve 1 over x? Well, from the shape of the function, we can see that will begin approaching 0, begins approaching the x-axis. So the values are getting less and less, and in infinity it will be 0. So this whole notation just asks this simple question. And we also get overwhelmed by new notations, and I've taken it upon myself to introduce the notation before I begin the concept of any concept, be it derivative, the limit, the integral, any other concept. I begin by explaining the notation. For example, have the sigma notation, where n you have, for example, 1 over n to the power of 4. N begins from 0 up to 20. This is just the summarized way of writing 0 to the power of 4 plus 1 to the power of 4 plus 2 to the power of 4 up until 20 to the power of 4. And because we are lazy in mathematics, we come up with new ways of writing stuff. And this is the whole point of the notation. So learning how to read math can be so